Okay, this is the third video in the playlist that deals with solutions and molarity. In the first two videos, what I did was I introduced the concept of a solution, and then the following video we delved into the definition of molarity and how to calculate basically the concentration of a substance that's been dissolved in water to make a solution. And what I want to do now is take a look at what I consider the perhaps the most common two examples of calculations that are involved in the laboratory in order to make solutions. And these would be calculations that students would encounter in their high school chemistry labs or advanced placement chemistry labs or general chemistry at the university level chemistry labs. All right, now the first type of problem that you might encounter is when you have a particular volume of a certain molarity solution that you need to make because you're going to carry out an experiment or some kind of a process in the laboratory where you're going to need to utilize this solution to do something else. So for example, let's say that we needed 3 liters of a 1 molar solution of NaOH, all right, of sodium hydroxide. Now, to put a visual on this, I'll just draw a beaker over here or a carboy or something that's going to be holding this solution, and it's going to have a total volume in it when we're done of 3 liters of total solution. And the material, the sodium hydroxide, will be dissolved in that solution. Remember from the previous video and actually previous playlists that I have uploaded, remember that when we dissolve an ionic compound into water to make a solution, the ionic compound is fully ionized. So what we want to do is produce a 3-liter solution of 1 molar NaOH. And the question is, how do we do this? All right, the first thing is that you need to make sure that you understand what the units of molarity are. So I'm going to expand the units here. So what we're after is a final solution that's going to be 1 mole of NaOH, all right, per liter of solution. So here are the units of molarity. It's particles per liter. And if you look at the volume that we want, we need 3 liters. All right. So the first thing we're going to do is find out how many total particles we're going to need of the NaOH. And so what we're going to do is just simply multiply the molarity of the NaOH times the volume that we need to produce. All right, and you can see that when we do that, that the liters are going to cancel out and we're going to be left with total particles. So we're going to need a total of, I'm going to put it over here, we're going to need a total of 3 moles of sodium hydroxide. Now, sodium hydroxide is a common, well, it's one of the 5 strong bases, and it's a common laboratory reagent. It comes in a bottle, usually in the form of little white pellets. So what we're going to need to do now is find the mass of the NaOH so that we can use a scale to mass out the amount of this that we're going to need that will be equivalent to 3 moles of NaOH. So we're going to multiply the 3 moles of NaOH by its molar mass, which happens to be 39.998 grams per mole. Now, if you're kind of a newbie to this, I didn't just pull this number out of the air. Okay, I calculated it based on the molar mass of the respective elements that make up this compound. Okay, so I'm going to run through that quickly. The sodium, when you look it up on the periodic table, is 22 0.99 grams per mole. The oxygen is 16. All right, and the hydrogen is 1.008. All right, and when you sum that together, you're going to get 39.998. So the amount of mass of NaOH that we're going to mass out on a scale is going to be 119.994 grams. Okay, now logistically, the way that we're going to make this solution is worth talking about, because in the laboratory you'll be responsible as a student to do this. So what I'm going to do when I make this solution, what I do is I'm going to get some kind of a large beaker or something that's going to hold the total volume of my solution, and I'm going to put some water in it. I'm not going to load the beaker up with 3 liters of water, right? I'm going to put enough water into this so that I can conveniently dissolve the mass of NaOH, for example, that we massed out here. So I'm going to put this in here, and this thing might be sitting on a stir plate of some kind, or, you know, depending on how sophisticated your lab is, you may have to stir it by hand, whatever the case is. But you'll put the mass of NaOH in here, and you will, this would be the little stir bar, all right, and you'll get the material to go into solution, and then depending on the precision that you need, it may well be that you're only going to have to that you could use a beaker to do this, or you might have to put the solution together in a graduated cylinder. So after the sodium hydroxide dissolves, then what will happen is you'll adjust the final volume to 3 liters using H2O, so that you have the correct volume of solution that you need, that we wanted to make. And when you've done this, when it's complete, then you will have successfully produced a solution that's the right concentration. It's 1 molar NaOH is what we were after. And now you've got what you need in order to do whatever it was that you were making the solution for. Perhaps you need it for some qualitative analysis, or maybe you're actually going to use it as what we call a stock solution, from which we can use samples of this solution that can be diluted to make other solutions of NaOH that will be more dilute. So, for example, maybe we need to make a solution of 0.5 molar NaOH, and we would use a fraction of this solution to do that, utilizing this equation here. And I'm actually going to discuss this. I'm actually going to discuss this issue in the following video. So let me just put up the equation for calculating molarity of solutions that are going to be produced by dilution, and I'm going to close the video here.